Now let's discuss this load transfer mechanism by yield line theory for the two-way slab. So you might know two-way slab. Two-way slab is that for which Ly is less than or equal to 2 times Lx. Lx is shorter dimension and Ly is the larger dimension. Now first I take for B3 and B4. For beam B3 and B4. This is beam B3 and this is for beam B4. For beam B3 and B4, load per running meter would be W Lx upon 3. Sorry, W Lx upon 3, where Lx is the shorter dimension. Do not forget, Lx is always the shorter dimension and W is load per unit area on slab. So that's it. So in same way, we can calculate beam load per running meter on B3 and same for B4. Now let's discuss it. Actually, this mechanism has been decided by the yield line theory. Yield line theory is one of the most important chapter in RCC. You might have studied this in your BTech programs. So according to the yield theory, the total load on the slab can be divided in such fashion. That's why we analyze it in this way. Okay. Now I just proceed for beam B1 and beam B2. So load per running meter for beam B1 and B2. So if you go through different books, different professional designer book, you will find three formulae. You will find three formulae for calculate the load on beam B1 and B2. So I explain all of them. What are those formulae? First formula is W Lx upon 2 1 minus 1 upon 2 R. Second formula is W Lx upon 2 1 minus 1 upon 3 R square. And third formula is W Lx R upon R plus 2. To note it down, the load per running meter for beam B1, B2, different writer mentioned different formula to calculate load on B1 and B2. First formula this, you can use any one of these two formulae to calculate the load on these beam, where R is equal to larger dimension upon shorter dimension. R is the ratio of larger dimension and shorter dimension. So if you ask me what is the most useful formula to calculate, so I have gone through so many books, but I found most of the designers, most of the professional engineers go through for this formula number 1. They use this formula. So this is very practical formula. If you are designing the beam, you can use this formula. This is simple, easy and most using formula. Okay. So I just advise you in your professional life, just use this formula to calculate the load on the beam B1 and B2. Once you have calculated the load on B1 and B2 in such a way, this is per running meter load, then you can find out the total load coming on column C1. Let's suppose this column is column C1. If you want to calculate the what is the load coming on the column C1, it is very simple. You have calculated this load per running meter on the beam B1. If you multiply this load by the load Ly, you will find the total load on the beam B1. Once you find the total load on the B1, you can divide this total load in two equal parts. One part will go this column and second part of load will go through this column. So in this way, you can find load on the column C1. In same way, if I consider this triangular portion, as I have calculated load per running meter on the beam B3 is nothing but WLX upon 3. If you multiply WLX by 3 by LX, then you will find total load on the beam B3. Once you find the total load on the beam B3, you can divide it in two parts. One part will go through column C1 and another part will go column through C3. So in this fashion, you can also calculate the total load coming on the column C1, just dividing the total load on the beam on two equal parts. This is very simple. This does not only guarantee you to calculate the load on the B1, but it also gives you the total load on the column C1. So this is most useful concept. If you want me to calculate this analysis by using some value of W, then I can do it in further lecture. So if you find any difficulties, any confusion for this one-way slab or two-way slab, you can ask me on the comment section. Now one more topic is there. One more case is there. In this case, Ly is less than 2Lx. If somehow Ly is equal to 2Lx. One thing I forgot, just mind this value and this value is Lx upon, I write it here, this value is Lx upon 2. Also, this value is Lx upon 2. Hence, this value Lx upon 2 plus Lx upon 2 becomes Lx, and this is Ly. Then Ly minus Lx. This rest portion will be Ly minus Lx. Okay. I only add that this portion is Lx by 2. Okay. And this portion is also Lx by 2. So this remaining portion is Ly minus Lx. Okay. Now I proceed. What happens when Ly is equal to 2Lx? In that case,